The first class of compounds that we're going to study in this course are going to be the alkanes. Alkanes, hopefully you recall, are hydrocarbons, which mean that they're only composed of carbon and hydrogen, and alkanes are only composed of sigma bonds. As far as physical properties go, they only exhibit dispersion, and as the length of the hydrocarbon chain gets longer, the dispersion increases. So for example, in the molecule on the top, where we have 1, 2, 3, 4, 5 carbons in a row, compared to the molecule on the bottom, 1, 2, 3, 4, 5, 6, 7 in a row, the molecule on the bottom is going to exhibit more dispersion between molecules of itself. And so there's more intermolecular forces holding those together. Therefore, you're going to see a reflection in the boiling point. It's going to have a higher boiling point than the shorter chain. The other thing about dispersion is that it can also be affected by shape. So for example, here, even though these are both composed of 4 carbon atoms in a row, you see that the structure on the left is more compact, more spherical than is the structure on the right. And so the more spherical or compact alkane has less dispersion because there's less surface area here. And when there's less dispersion taking place, it doesn't take as much energy to get the molecules to come apart. So in boiling point, we see that this has a lower boiling point than the more elongated structure on the right that can exhibit more dispersion. As far as solubility goes, alkanes are not particularly soluble in water. They can range anywhere from being very sparingly soluble to what we would consider completely insoluble. And really the main thing that we use hydrocarbons for are their physical properties as waxes and oils and lubricants. And the other thing that we use hydrocarbons for a lot is that we burn them for energy. There are no sites of nucleophilicity or electrophilicity in an alkane, and so they are not particularly reactive, but they can undergo combustion, which is very important for us on this planet.